Hello, welcome to the Chuck Darwin Show. I'm thrilled to be down here to welcome you to my show. Usually, of course, I'm up there. But up there, we may be dead, but we do follow what's going on down here. We care about humanity, where it's heading. In fact, we care so much, we said, I should come down and talk to you. And that's how the Chuck Darwin Show came about. I'm here to talk to you about something very important, perhaps most important of all, the quest for meaning in life. We're quite alarmed up there about what we see going on down here. About a century ago, we noticed you abandoning the search for meaning in life. Instead, you began searching for meaning in machinery. We want to warn you, you won't find meaning of life in machinery. The only meaning in life you'll find in machinery is whatever meaning you put into it. Any other meaning you get out of machinery will be meaning about machinery, not about you. I was voted the one to deliver this message because my theory of evolution, it was purely physical. It's what most made you think of yourselves as being purely physical too, purely mechanical. So it had to be me that came down to tell you I was wrong, and you should turn back from thinking of yourselves as machinery to look for meaning in being alive. First, about that theory of mine, natural selection. Remember Mad King George, who made America stop being a colony? I was born back in his reign. My voyage on the Beagle to the Galapagos, by the time I returned, Victoria was still just a teenager, the future Queen Victoria. My science wasn't even Victorian, it was pre-Victorian. We still thought in terms of alchemy. I titled my first scribblings about evolution my Transmutation Notebook. Obviously, the concepts available to me then, they were no match for the mysteries of evolution. My theory of natural selection, I've long since abandoned it. But I'm still curious about the origin of species, so that's why, up there, I got together a small group of fellows. We follow every new discovery, about the genome, for example, and we ask ourselves, what does all this mean for the origin of species? What I'll do in my show is, I'll tell you what I think all this means for you now. Let's see, how was I supposed to begin? It's suddenly all come to seem very complicated. Problem is, we up there have come to see the universe very differently from you, and I'll have to tell you about that first. How we see reality is as presenting itself to us like a crystal through a number of different facets, each one an entire world of its own. We got the idea from you, from the great scientific discoveries of the 20th century, two entirely different views of the universe, a quantum world and a physical world. And we see the quantum world as implying a third, a world of pure energy preceding it before the Big Bang. Of course, it's all the same universe, it just looks like a different world each time we come up with a new way of looking at it. We call these different ways of looking at reality worlds with a capital W. Three different worlds: energy, quantum, matter. To these we added two more worlds, consciousness and the self, two more faces of reality. We were looking at the universe this way as a series of separate worlds to see if it could help us come up with a new origin of species. Was there some natural order in such worlds? Right on cue, who should amble by but Mendeleev, the guy who found a natural order in the chemical elements. His periodic table. 5 worlds, we said, and in a moment he'd arranged them in a table, with the three worlds you came up with, energy, quanta, and matter at one end, and at the other end, consciousness and the self, meaning and life. In the middle, between them, he left a gap. He said, "You're missing a world in the middle. You'll need that world to join the other worlds altogether." It seemed worth trying. So we set ourselves to identify the missing world at position 4. That's where the gap was between your sciences and what's traditionally given meaning to life, consciousness and the self. Finding that world would join all aspects of reality together, making sense of everything, species and all. So there's our table with energy, the quantum world, and the physical world of matter at the bottom. Then a gap. Then consciousness and the self at the top. A quick review of where we are. I'm down here to help you find meaning in life instead of in machinery. A little group I formed up there to explore the origin of species came up with something that could help you. But to explain it, I have to tell you how we see things in terms of separate worlds. So now I'm going to tell you about these worlds. As we go, please notice, it's very important how different these worlds are from one another. They have entirely different properties. They become entirely separate and distinct. You can't apply what you learn about any one world to know what's true of any of the others. World 1, energy. We had to just make up this world to have a starting point. This world is pure energy. Before the Big Bang, the world presented to us only this one face. Special about this world is it has no dimensions, no space, no time, no scale, just pure energy. World 2, quantum. With the Big Bang, the world presents to us a second face. Energy manifests itself as quantum particles. With quantum particles come into existence the dimensions of space and time. Quantum particles joining together to form hydrogen atoms and helium. The prevailing scale in this world is atomic. Special to this world is uncertainty. Causes for things cannot be pinned down. It is not deterministic. World 3, physical. Gravity draws the quantum stuff together into stars. Inside stars, gravity crushes into existence all the other elements, what we call physical matter. There's a change of scale from that of the quantum and atom to everyday physical matter. At this scale, human scale, matter manifests itself as solids, liquids, gases. What else is special to this world besides its scale is everything's physically determined. Physical laws acting at any one moment determine what will happen in all future moments. This rules out uncertainty or creativity. Being creative, creating something new and meaningful that wasn't implied in the previous moment, would defy physical determinism. So there's the first three, the ones you're responsible for discovering. There's no meaning of life possible here. For meaning in life, you have to look beyond these three worlds to the other worlds in the series. Now, for a moment, let's skip over World 4, the missing world, and look at Worlds 5 and World 6, the two worlds of consciousness and the self. You know they exist. They're like windows. It's through them you experience Worlds 1, 2, and 3. Denying reality to consciousness and the self would be like you denying you have ears and eyes. But compared to Worlds 1, 2, and 3, the worlds revealed by science, you've come to find mind remote and unreal. I know. You've no laws to apply to consciousness and the self. You've very few concepts for thinking about them. You've lost even the old traditional ways of talking about them. But this is where we feel true meaning in life lies. Our goal is, by filling in World 4, to give you access to Worlds 5 and 6 once again. So it's to the missing world, World 4, I'll turn next. If you want to take a break for discussion, I suggest you do it here. Okay, we're back with the Chuck Darwin Show. I needed that break. Where were we? Oh yes, the missing world, World 4. What is it exactly, we asked ourselves, what is it that makes living creatures so different from just matter? It was two members of our own group, biologists, William Bateson and his son, Gregory Bateson, who came up with the answer. What's special about life, they argued, is it's made up of patterns of connection. Patterns of connection. What is a pattern of connection? It's like a switchboard, they explained. It takes signals in at one end, sorts them through a set of switches, so they come out sorted at the other end. You've seen those coin sorting machines at your bank. You pour loose change in at the top, it comes out at the bottom, sorted into separate piles of nickels, dimes, and quarters. It's like that. It sorts things. You're all familiar with that? Imagine something like that, only much, much bigger. A vast switchboard, a sea of switches and gates that can sort whatever you pour into it. And you don't have to tell it how. It learns how. It trains itself. Down here you call that artificial intelligence. An artificial intelligence machine called AlphaGo recently trained itself to play the game of Go. In just a year or so, it got good enough to beat the world champion. It trained itself. You all familiar with this, with artificial intelligence? That's an example of a pattern of connection, a huge switchboard that can train itself to solve problems. And that, the Batesons told us, is what makes living tissues so different from things made of solid matter. Things made purely of matter are usually the same all the way through. They get their properties from the elements they're made of. But living stuff gets most of its properties from how it's structured. Living tissues are structured. Think of your kidney. Cut it open. You'd see a network of blood vessels feeding in and tubes for urine leading out towards the bladder. That's one pattern of connection. Now look at your kidney under a magnifying glass and then a microscope. At each succeeding scale, you'll see different patterns of connection right down to the molecular level. Your kidney is not made of a lot of different elements. It's made up of patterns of connection through and through, right down to the molecules it's made of. Muscles, the muscles of our back, our arms, our legs, they're powered by what's happening down at the atomic scale, by molecules of actin and myosin sliding alongside each other. But that's not all, because it consists of patterns of connection. Life can be intelligent. You know that. Patterns of connection built into a machine can turn it into a world champion in games like Go and chess. That's pretty intelligent. If patterns of connection can do that, then they can certainly make even the simplest forms of life intelligent. Your kidney acts very intelligently. Now, I'm not saying conscious yet, I'm just saying intelligent. What else can we say about patterns of connection? They can make new patterns of connection, the Batesons told us. And if those new patterns of connection need new substances, they can come up with them as they need them. Our genome codes for 20,000 different proteins, which, I don't know, that may be more than all the naturally occurring physical stuffs in the universe. So because it's made of patterns of connection, life can make new substances, consisting of new patterns of connection, whenever it wants. patterns of connection can grow themselves and multiply. Even what causes what works differently. In the physical world, you account for the properties of things in terms of what's going on at the atomic level. That's reductionism. It's how things are at the atomic scale that explains how the stuff you're holding in your hand looks and feels. Causation works from the atomic scale up. But life, you can't be reductionist about life like that. In living creatures, causation works top down. It's how things are in the living creature at the atomic scale is driven by how the creature as a whole is doing, adapting to its environment, for example. If life is driven by the needs of the whole creature, not by what's happening to the molecules it's made of, causation works from the top, the whole creature, down. The opposite of how it works in physical matter in World 3. And biggest difference of all, they told us, and essential for evolution, is patterns of connection can defy physics. They can be creative. That's what's most special about them. They can learn what's likely to happen next. They can predict it and make something else happen. That's like us saying, it's going to rain tomorrow, so I'll take my umbrella and I won't get wet. I use reason to defy physical determinism. Engineers down here building artificial intelligence into machines, they soon found themselves unable to understand how their machines reached their conclusions. Patterns of connection quickly become much too complicated for today's physics to set limits to how they work. Patterns of connection can predict what's likely to happen next, but you can't tell how they do it. You can't tell from what's happened in one moment in one of these machines what will happen in the next. They make it up. And because that's true for patterns of connection, it's also true of life. Life can be creative. So here's a summary. Living creatures are made of patterns of connection. As a result, life can grow and multiply. In living creatures, causation works top down, from the whole creature down to the atoms it consists of. And because it's made of patterns of connection, life can be creative. This was hard for us to get our heads around at first. But once we got used to it, to life being how it was because of how it was structured, how differently it was made, we wondered how it could ever have been lumped in with physical matter. Because it was made up of patterns of connection, we decided life deserved to be given a world of its own. What about species? I asked Bateson Sr., William. If patterns of connection can account for life, could they account for the origin of species? You've told us how patterns of connection can be creative, they can be intelligent, they can design each other. Old patterns of connection can evolve into new patterns of connection. Could that amount to an entirely new mechanism of evolution? If you read my book on the origin of species, you'll know I originally supposed that life began in some warm puddle exposed to air and sunlight. But according to the older Bateson, life more likely began on the walls of vents at the bottom of the sea. He pictured the earliest oceans on planet Earth as having been crisscrossed with vents pouring out molten volcanic rock and fumes, blisteringly hot. A vast test tube of violent chemistry. Now go back for a moment to World 2, the quantum world, he said. What's been discovered about empty space? It isn't empty. Quantum particles can pop in and out of existence all the time. Like that, on the superheated clay walls of those vents, chemical switches will pop in and out of existence. In that cauldron of hot chemicals, wherever such switches could provide shortcuts for the flow of energy, they'd organize themselves into sheets, patterns of connection, covering every surface. In effect, he said, patterns of connection like that would amount to chemical factories. Depending on the energy flowing over them, they'll automatically process chemicals into new combinations with lower energy. Over time, some of those switches will bind catalysts, speeding up those reactions. Among those catalysts will be proteins, what we call enzymes, he said, and with that we come to the first sign of what we think of as life. Sign of life number 2, certain patterns of connection, really recipes for chemical cookery, get written down in RNA and DNA molecules. And for these recipes to spread from place to place, perhaps from one location within a sheet to others, copies of those molecules wrapped in a protective coat get released into the ocean. There's the invention of viruses, little floating chemical recipes. Then strings of those recipes join up into genomes, and together with the enzymes needed for reading them, get packed into little sacks and released to set up shop on another vent, perhaps far away. That's the invention of microbes, each with its own genome. Sign of life number 3. The oceans became a soup of living chemistry, viruses and microbes sharing much of their DNA with one another, splitting into new species. There's the origin of species. And that is how things seem to stay for over half of how long the Earth existed. With that, the older Bateson, great biologist of the early 20th century, sat down. His son Gregory, more focused on what happened next, took his place. To understand what happened next, he said, you have to know more about the genome, what a genome is. It can come as a number of separate molecules, but I'd like you to think of it as a single long molecule. Along it are stored in linear code all the patterns of connection needed for making up a living creature. Duplicate that string, and with the right enzymes you can read back those patterns in the code to make a new cell. That's how genomes started. If you'd been there bobbing about in that soup of living chemistry, you might have said, "Nothing's happening," he went on. But something very important was happening. The genome was gathering new powers, new engines, new processes, greater intelligence. And why do we think that? Because of what happened next, around 1 billion years ago. Two things in particular tell us evolution had reached greater powers, evolved greater intelligence. Of course, we knew all about this, but it was useful to have it all summed up so simply. First sign of evolution's new powers, he said, was the sudden appearance of an entirely new kind of cell, much more complicated, like a giant sac with whole colonies of microbes inside it. And in the middle, in a separate sac of its own, what got called the nucleus, sat the genome, and along with it, new equipment giving it entirely new and greater powers, much greater control over the manufacture of proteins. This was the kind of cell we're made of. Second indication of evolution's new powers, it created something entirely new. Meiosis, sex. Creatures came divided into males and females, their genes fusing in a much more elaborate process of cell division. In this intricate dance, male and female genomes could arrange their genes into patterns of connection on the genome, making for much more advanced new creatures. And because genes get copied from generation to generation over time, these genomes could accumulate a new kind of wisdom. Which patterns of connection made which kinds of living creatures? Creatures could now be designed intelligently by their genomes for new environments. You all know what came next, he said, what this made possible. Creatures like us. We're made up of trillions of cells of over 200 different kinds. Muscle cells, nerve cells, and brain cells. All radically different, all coded for in the genomes we carry within us, in the nucleus of each cell in our bodies. Key to these new powers was a new tool set. And key to this new tool set was the genome being reorganized into patterns of connection. Now, the genome didn't just code for intelligence, it itself became intelligent. We'd been sitting quietly, about 15 or 16 of us, but at the idea of a molecule becoming intelligent, we erupted in a storm of objections. But talking it over, we agreed he had a point. The genome's astonishingly long. Stretch it out and it would be a molecule 6 foot long. That's a lot of information. And it's been evolving for 1,000 times as long as our brains have. So we've actually nothing to compare it to try to imagine how intelligent it could be, except our own brains. Anyway, our brains are made of molecules too, yet we're intelligent. That's sort of how we define intelligence. And of course, our brains develop in us entirely under the direction of our genomes. So our brains must come pre-coded for in the genome. The patterns of connection needed to construct our brains with all our intelligence and all the wisdom we come into the world with must make up just one small part of our genome's intelligence. Think how much intelligence it must take for us to grow from a single cell to trillions of cells of over 200 different types. So logic suggests the genome must be intelligent. In fact, vastly more intelligent than we are. I spoke up. What's a brain for? I asked. It's for writing patterns of connection into, he said. Once we had brains, the genome could build into it little branch offices for itself. Into our brains, it could embed some of its own wisdom for us to draw on for ourselves. It gave us minds. Minds. So having a brain gives us a mind. What's a mind? I asked Gregory. Think of a computer, he said. Sometimes engineers want their computers to carry out some special kind of calculation. So they add registers. Let's think of those as concentrations of intelligence. From anywhere in the computer, a problem can be sent to a register and the register returns the answer. Now picture our intelligence as a sheet of patterns of connection, like a large sheet of paper, and add registers to it one at a time, a thickening of the surface raising bumps. One, of course, would be for memory. Another one, a fat bundle bulging up out of the sheet, would be for vision, hearing, pleasure and pain. Actually, when you think about it, that's like what a brain is. Think of it as a sheet about the size of a small tablecloth. Scrunch it up so it's all wrinkled. Shape it into a hollow ball with the registers all sticking out. Then turn it inside out so all the registers lie pressed together inside the ball, and you've got a brain. We amused ourselves imagining the registers all jostling for best connections to the sheet around them. One in particular stood out as particularly important, and that's attention. That's a way for any part of the brain to focus all the brain's resources onto something particular. And once you have a module like that for issuing alerts, you need other registers for signals to label your alert with. One register for signals for kinds of danger, snake, lion, crocodile. One for opportunities, fruit, water, shelter. These are signals for meaning. Associate those meanings with calls and cries, and languages aren't far behind. Now we have a shared system of meanings. Our little group, we looked at one another. We were pretty pleased with ourselves. We'd been able to take the Batesons' concept of patterns of connection and plot a path for how it evolved all the way to having minds. Good time to break for a discussion if you've a mind to. First though, here's a quick summary of what we'd come up with. What's distinctive about living creatures is they come structured as patterns of connection. Old patterns of connection can evolve into new patterns of connection. Patterns of connection can transcend the limits posed by 21st century physics to become intelligent and creative. Through genes being reorganized into patterns of connection, the genome became intelligent and creative. The genome gave creatures brains so it could embed into them some of its own patterns of connection, its own wisdom. These patterns of connection evolved registers for memory, sensation, attention, and meanings, resulting in minds. Now, a break. And now, I'm going to continue with my show, The Chuck Darwin Show. How World 4, the world of life, prepares us for World 5, consciousness. I wonder what questions have occurred to you. Here's a question that occurred to me. We talked about the genome. Which genome? Where? In which cell? This one here on my hand? This one here on my face? As I was turning this question over in my mind, I was gazing at a tree and admiring its branches stretching out on each side towards the light as if eagerly reaching out for energy, which of course they were. Suddenly I wondered, how did the tree remain so symmetrical? How did the branches on one side know at each stage of the tree's growth how far to grow to match those on the tree's other side? Or take a whale, as it grows, how does one flipper know how much to grow to be as long as the other flipper, and then when to stop growing so they both stay the same size? Obviously they do, those flippers, or we'd see young whales swimming in circles, and we don't. What keeps living creatures symmetrical and in proportion as they grow? What could control growth like that over distances of hundreds of feet? As I gazed at the tree, everything about it faded away until it consisted of nothing more than the genomes in its cells. It became luminous. There was a spot of light in every cell. Every leaf glowed. Then every node where leaves met twigs, where twigs met branches, where branches met boughs, and boughs joined the trunk. It was a festival of light. It's the tree of life, I thought. The leaves are species, the twigs are families, the branches are genera, the boughs the phyla, the trunk is all the living kingdoms joined together. When I sort of came to, I had my answer. The intelligence of the genome is dispersed throughout nature. Genomes can read each other's minds. They can think together. They can form thinking communities at every scale of life, maintaining it, directing its growth, its evolution. I reviewed everything I knew about nature. Yes, I thought it must be true. So that was one question answered. Which genome? All of them, working together. The next question was something of a surprise. I was visiting my buddy Galileo up there and telling him about what we'd come up with. I told him about patterns of connection and the genome and it being intelligent and how that gave us minds. It was all so much I wondered if he'd be able to take it all in. He fell silent. I waited eagerly for his approval of what we had achieved. Instead, all he said was, "What happens when a genome thinks?" I was stumped. Next time our little group met, I posed them Galileo's question: what happens when a genome thinks? "Well, what is thinking?" someone asked. "What happens when we think?" We agreed that when we think, when we remember something, for example, we make changes to brain cells, something physical. Later we can read that memory back from those cells and think about it again. "So where's the genome's brain?" someone asked. We agreed it must consist of all the genes strung along the genome's chromosomes. A little hush fell over the group. I'll never forget it. It's genomes that define species. If by merely thinking the genome can change a species' genes, then it can create new species merely by thinking them up. We'd arrived at an entirely new mechanism of evolution. For you, the concept of species being thoughts in the mind of a genome may be hard to get your minds around. For us up there, it wasn't as hard. That's really all we are up there. We're basically our ideas. What caused a hush to fall over us was we'd stumbled on an entirely new mechanism for evolution. For me, what was most important was it gave living creatures a new dignity. If species of living creatures consisted of thoughts, then they could evolve not as collections of characteristics, as I had supposed, but as wholes. We'd achieved our original goal of coming up with a new origin of species. But along the way, our goal had changed. Now we wanted to join your new worlds 1, 2, and 3, with where we believed the meaning of life lay in worlds 5 and 6. With input from Mendeleev, then the Batesons, then Galileo, we'd made considerable progress. Now, who should we approach next? Newton. Einstein, came the suggestions. Newton was too much into alchemy for my taste, so we settled on Einstein. It was weird. Instead of coming in person, he sent a kind of robot, a sort of stone tablet on wheels. It took its place among us. Little flames etched a message across its surface. "Tell me," it said. So, addressing this stone tablet, I felt a little foolish, I must admit. I repeated what I'd said to Galileo, and others brought up our new mechanism of evolution. And then we waited. Little flames began inscribing a new message on the stone. A longer message, but still in one line. "For genome," it said, "ideas evolving equals thinking." Okay, that we knew. It began a new line. "For human, thinking equals ideas evolving." Thinking was our ideas evolving, our thoughts evolving. Thinking in us is one thought evolving into another. Well, of course, what other kinds of processes were there in World 4? Thinking had to involve something evolving. Ideas, our thoughts. We buzzed about this for a while. Then someone asked, "What is consciousness?" Flames once more picked out, letter by letter, a new message. Conscious experience equals a function of thoughts evolving. With that, the tablet wheeled around and trundled off. Our thoughts evolving we experience as consciousness? We had our answer. Or did we? Was this really an explanation? Did it help us understand consciousness? Well, in a way, yes, that's all understanding is, an explanation, with something you can't apply science or mathematics to, like consciousness, because it's creative. Once you're happy with an explanation of it, you feel you understand it. What else is understanding? Consciousness is a function of our thoughts evolving. What about the genome? If species evolve because the genome thinks, then the genome must be conscious too. It too must be creative. It too must have what we call in ourselves free will. In fact, of course, that must be where we get those from. We're creative and have free will because the genome's creative and has free will. These are all characteristics of patterns of connection. At last, with thinking equals evolving, and consciousness defined as a function of thoughts evolving, we'd opened a door into the next world in line, World 5. Time for another break. World 5, the evolution of consciousness. Here I am, back to continue my Chuck Darwin show. I have a secret resource. Well, you may know about him. My grandfather, Erasmus Darwin. He's been called one of the last great thinkers of the Enlightenment. In 1794, 15 years before I was born, he published a 200-page book. The second 100 pages dealt with an idea novel enough to get the book circulated throughout Europe. He did for diseases and physical disorders what Linnaeus had done for kinds of living creatures, arranging them all in a tree according to how closely they resembled each other. A remarkable tour de force. But the first 100 pages were even more remarkable. How we humans evolved, the world's first account of evolution, in 100 pages. A very great variety of species of animals may have their origin from the mixture of a few natural orders, he wrote. He outlined all later mechanisms of evolution, even mine. Listen to this. Every individual tree produces innumerable seeds, and every individual fish innumerable spawn, in such inconceivable abundance as would, in a short space of time, crowd the earth and oceans with inhabitants. He was also a published poet. Compare that with my more individuals are produced in each generation than can survive. He went on, this argument only shows that the productions of nature are governed by general laws. For a general law, I had only to turn to something Malthus published only 4 years later, in 1798. Increase of population is necessarily limited by means of subsistence. There it all was, more than a decade before I was born. Natural selection through competition for scarce resources. I only grudgingly gave my grandfather credit in my lifetime. I'd like, as far as I can, to set the record straight. 200 years before it was discovered, I see him having conceived of the genome. He refers to spermatozoa as living filaments, partly alive, partly mechanic springs. Isn't that how we picture the genome today? He invites us to suppose that all warm-blooded animals have arisen from one living filament. And later, one and the same kind of living filament is, and has been, the cause of organic life. Where was he now when I needed him? Well, nearby, of course. I paid him a visit. I looked forward to telling him about the genome, about patterns of connection, making the genome both intelligent and conscious, about how the genome could think new species into existence and the new mechanism of evolution that implied. I told him how, from early microbes to us, from several hundred genes, the genome would eventually grow 1,000,000-fold to billions of genes. He listened intently, unusual for him, usually a most garrulous man. Eventually he spoke. He began with the 2 billion years between the first microbes, mere bags of chemicals splitting off the walls of the ocean vents, and the appearance 2-3 billion years later of the giant nucleated cell and the elaborate process by which they reproduced. So life began as patterns of connection on the walls of superheated vents in the ocean depths, he mused. I'm modernizing his speech and translating into English the Latin quotations he liked to sprinkle through it. He turned our thinking inside out. The circulation of patterns of connection in the form of scraps of RNA and DNA among those molecules would result in the evolution of innumerable new species. Fine. So many species evolving would in turn constitute a torrent of new ideas. He was seeing the genes in a species as an idea before there was a mind to think them. That torrent of ideas in turn would elicit the brain they needed for their physical support, to serve as a brain, as complex patterns of connection in the genome. So for him, it was species evolving that induced intelligence into the genome. This genome, evolving intelligence and creativity over 3 billion years, could then think into an existence an entirely new vehicle for life, a giant cell, with the genome, much enlarged, enthroned at its center in a nucleus. Then, for greater control over the evolution of species using this platform, it invented sex. This confined the circulations of patterns of connection within silos made up of the genomes of males and females of each species. In another billion years, those patterns of connection would have evolved sufficient intelligence to code for creatures with trillions of cells of more than 200 different types, and brains informed with all the smarts each human being is born with minds. In these sex-limited silos, intelligent patterns of connection evolved exceedingly rapidly. It was to accommodate that ballooning intelligence that the genome assumed the monstrous length it displays in creatures such as us. So for him, it was not the genome that first evolved. Rather, the evolution of the genome was the result of all those early species evolving, of so many new ideas that forced into existence new genes to be the brains they needed to think them. I thanked him for his thoughts without altogether understanding them till later. I think, though, he realized how little his grandson had been able to comprehend. Evolution isn't about us, he said, speaking simply. It's really about the genome. First, the genome had to evolve enough to become conscious before it could make us conscious. Else, how could it know how? Living creatures like us, we're merely vehicles for the genomes. Most living creatures are intended for nothing more than to be offered as prey. Each genome provides for the nourishment of other genomes, creatures. I was aghast. Is that all we mean to genomes? Is meaning in life for living creatures nothing more than being prey for one another? Reporting back on my grandfather's response, I told my little group, I can't believe it. There has to be more to discover about World 5, about being conscious products of a conscious genome. Else how could we graduate from World 5 to World 6, the self, where I believed true meaning lies? In fact, there was very little more we needed to discover. Remember, evolution being driven by patterns of connection had led to us having brains packed with registers for ever more advanced mental qualities. Primary among these would be attention. And availability of control of attention would have favored the clustering of registers into entire modules. Each module would be capable of directing a particular set of behaviors. Creatures' minds would be taken over in turn by any one of a number of highly specialized modules. Such creatures could be terrible killers. But then we were made conscious. What effect will that have on such a mind, we wondered. Eager to close out World 5, we simply supposed consciousness could dig new silos into the mind for tissues, giving it executive control over all those modules. The brain would become reshaped around these silos and the demands of conscious experience. Looking back on our own lives, some of us felt we had experienced this in ourselves as we had aged. This unifying of mental life through the exercise of consciousness as we age, we felt, was the foundation on which a conscious self could be built. We felt ready to explore World 6. World 6, self-consciousness. We'd reached some understanding of consciousness. It comes in association with thoughts evolving, whether thoughts in our minds or species evolving in the mind of a genome. It was time for us to apply that to an understanding of the conscious self. Our ultimate goal, after all, was to have blazed a path for you, all the way from the Big Bang to meaning in life. I put out a call. We needed an expert on evolutionary psychology, consciousness, attention, and the development of individuality. Most responses came from people active in the 20th century. But one response in particular intrigued us. I've been following progress in evolution closely, and it's obviously going nowhere. It desperately needs a good shaking out. I'm a terrific fan of little groups like yours, and I love what you've come up with. I've got World 6 already mapped out. I'd love to work with you. Signed, Leibniz. Leibniz? He's late 17th century, along with Newton. A good century, that, founding of the Royal Society and all. We asked him to join us. He introduced himself, then plunged right in. What's been the greatest achievement of the last 150 years? He asked us with a rhetorical flourish. He looked around to make sure he had our full attention. Not science, he announced. Public health. Have you noticed how few of those succeeding us up here now die in infancy? How much older most people are when they die? Life expectancy has doubled. Life has become much more secure. Human attention used to be taken up with grinding obligations, pleasures caught on the fly, periodic mourning for the death of others, and the prospect of oneself dying all too soon. Now that's all been turned around. A child born today is almost guaranteed not only a long life, but continual conscious experiences throughout the better part of a century. Forget the marketplace, forget economics. This is something entirely new to invest in, the reshaping of your brain around whatever it is you choose to devote conscious experiences to. Life savings will take the form of a conscious self developed over a lifetime. That's the new wealth. That's the meaning that from now on will define the conscious self. On and on he went, sometimes waving his arms around, accomplished statesman that he was. It was utterly brilliant, but I must confess I was totally overwhelmed. I had to ask my little group afterwards what he'd actually said. They gave me the main points. He complimented us on how we'd traced evolution's progress from the walls of ocean vents to viruses, to free-swimming microbes, to creatures made up of giant cells like ours, sexual, with brains, with genomes able to lay down in those brains some of their own patterns of connection. But these represented not mere markers along a steady progress, he said, but successive platforms evolution had created for itself to migrate to, each more glorious than the last, he'd said. This succession of platforms is the true meaning of evolution. And in this grand spectacle, what role has been reserved for humanity to play? Humanity has been picked out, has been equipped, is being prepared to become the next and most glorious platform through which evolution intends, in turn, to manifest itself. Phew. Okay. But how could we know we'd been picked out for this role? Because he claimed of how rapidly we had been made exceptional. In a mere 6 or 7 million years, a blink of an eye, we evolved an upright stance, fine manual dexterity, and along with a threefold enlargement of our brains, capacities for mimicry, empathy, language, reason, art, and science. Clearly, humanity had been selected for a role apart from and above that of the rest of the natural world. How very 17th century. What was our role to be? He contrasted my grandfather's somber words with our realizing that thinking is our thoughts evolving. No longer will our role in evolution be limited to being prey for other creatures, he said. Instead, evolution had endowed us with minds in which thoughts can evolve. Now we have century-long lifetimes, a century in which to perfect conscious experience. It is our thoughts that will evolve in our place. Human minds in which thoughts can evolve are to be the next platform through which the process of evolution will manifest itself. It is our destiny to become the most advanced showcase for evolution's mighty triumph. Okay, we're to be the next showcase for evolution's mighty powers. But what does that mean? What will humans actually have to do? Apparently he covered that as well. We must start by modeling ourselves on genomes. To do that, we have to get to know them personally, individually. One of us might study the personality responsible for the trilobites, which changed so radically throughout their long evolution. Another might study the personality responsible for sharks, which over many hundreds of millions of years hardly changed at all. What kind of transactions between genomes could have led vertebrates and arthropods to be equipped with such similar eyes? Rather than look for what makes all living creatures the same, look for what distinguishes them, but in terms of the personalities implicit in their differences. Someone in our group pointed out that we, up there, couldn't do that. In response, he issued these ominous words. Then you must send someone down to tell them down there about this glorious mission that's been thrust upon them and what they must do to fulfill it. And he went on to point out how vital this was, how humans were turning from looking for meaning in being evolved, living creatures, and turning instead to looking for meaning in machinery. The only meaning they'll find in machinery is whatever meaning they put into it, he said. Any meaning they do get out of machinery itself will be meaning about machinery, not about what it means to be human. Someone must go down and warn them, and tell them about this new meaning of life we've arrived at, about our seeing in life a new world, linking their sciences with our discovery of the true meaning in life. They must be told that how they, mere humans that they be, are to become giants, even as genomes themselves. Yes, that was going to take some explanation, he said, but he was sure there must be at least one person present who was up to the challenge. All eyes turned to me. That's why I'm down here. What actually is it I'm supposed to say? I remembered that bit about you looking for meaning in machinery, but the rest is all a bit of a blur now that I'm actually down here. It all seems a bit vague. Maybe you should get together in little groups as we did. Don't forget, like us, you may need a little help. Once we got beyond physical matter in World 3, the sciences became less helpful and we had to rely more on the humanities. That's how evolution started. My grandfather was a medical doctor and a poet. Robert Chambers was a journalist. Alfred Wallace and I were naturalists. Only Lamarck was a professional scientist. Perhaps it's been a mistake to think of evolution as being a sort of science. Maybe you should get the humanities back involved. I think this may be a good place to end the Chuck Darwin Show. Thank you, and goodbye.